Welcome to the third video in the Day of Datomic training videos. With the basics out of the way, Stu now moves on to Datomic's transaction model. In this video, we will see how Datomic is an old-school ACID database, and how Datomic allows you to group datums together into entities. Stu will also discuss how Datomic handles identity and the related question of uniqueness. Finally, Stu will cover database functions and reified transactions.
So we're going to talk about transactions. And we're just going to dive into it, because we got a lot to do. Wait for the, there we go. So Datomic transactions are ACID. ACID transactions have, it's an old acronym, right? This is something that most SQL databases do. And there are four properties. A transaction is atomic. What that means is whatever the transaction does to the system, it either does it or it doesn't do it, all as a unit. So in Datomic, a transaction is a set of datums being added to the system. That's always what it is. Right? Some of the datums are retractions. Right? They have the effect of making old things no longer true. But it's always additive. It's always adding datums to the system. And the A part of ACID in a Datomic context is if you make a transaction that has 40 datums in it, either those 40 datums are going to be in the system after that transaction, or they are not. Right? In other words, what cases don't happen? There's not a scenario where 20 of those datums are in the system and 20 of the datums are not in the system because of some sort of failure or a wire got cut or the power went out or any, those kinds of problems are not going to cause you to accidentally have some of the data in the system and not the rest of it. Consistent, the C in ACID, is do all processes see the same global ordering of transactions? Does everybody see things happen in the same order? And Datomic is consistent in the old-fashioned ACID sense. It's consistent in the newfangled CAP theorem sense. It's just freaking consistent, right? It's as consistent as you can possibly get. And in fact, if you look at SQL databases, they actually talk about transaction isolation levels, where you can turn down the ACID guarantees, right? You can say, you know what, and why would you do that? Performance, right? Why does the NoSQL movement say we're not ACID at all? Right? Performance, right? Write performance, volume. You want to be able to handle a large number of writes or a distributed large number of writes, then you want to turn these things down. Well, guess what? Datomic does not let you turn these things down. So in the old SQL world, the isolation levels go all the way up. They go from 0 to 3. And I love 0, chaos. Right? That's the actual mnemonic name for chaos, for 0. It's like, well, you threw some data at a system and maybe something happened. Which is an okay semantic. I have worked on a system. I've worked on a serious enterprise system where that was a completely legitimate semantic. Does that seem crazy? All right, so here's what it was. It's a system that was keeping a rolling list of suspect internet addresses where you think you've seen negative traffic for, to enable ISPs and other people to look at that suspect list and say, okay, we are going to not trust you because you're on that list. Well, what's the worst case scenario? If that suspect list, if it just randomly drops 5% of the things we write to it on the floor, what happens? The quality of identifying, the quality of pre-filtering those sites gets 5% degraded, right? But it's not like paychecks, right? It's not like somebody didn't get paid, right? It's not, so there are situations where it's okay to do that. Datomic is not a good system for things where you don't care, right? Datomic is for systems where you actually care about your data, or you care about each individual piece of it, right? Where it matters as individual datums, not just in aggregate. It's not something you're dumping log files into or whatever. Anyway, on the opposite of the scale, SQL describes level 3. Does anyone know what the mnemonic is for that? 0 is chaos. It sounds way better than chaos. Almost. Serializable. That means the things happen in the system as if they had been serialized. They don't have to have been serialized. But the highest level means that in the face of problems in the system, you can never tell that things weren't just actually serialized. And advanced systems do all kinds of clever things to preserve that property while trying to allow parallel execution? Well, we take a much simpler approach with Datomic. You know what? Things are just serialized, right? It's a single writer system. So it's incredibly easy to reason about. You know why things all happen in a global order? Because things only happen in one place. Well, it turns out if things only happen in one place, this is not a very difficult invariant to enforce. So strongly consistent. Isolated. This means that you never see other transactions, other stuff in process that hasn't been committed yet. Well, this falls directly out of being a single writer system, right? There is nobody else. Again, these properties are super easy when you make this particular assumption. And then finally, durable. And what this means is that with Datomic, the results of the transaction are flushed through to durable storage before we tell the person who made the transaction that their transaction is complete. So Datomic's role, and here when I'm being Datomic, I'm being clients, peers, transactors, the whole shebang, right? You get a transaction request, you turn around and tell storage, store this. If you're trying to build a system that can pretend to be really fast, you know what you tell the client? Right? There's a couple things you could do. You could say, you know what? Yeah, I got that, before you even tell anybody to store it. Or you could tell somebody to store it and then tell the client. Or you could tell somebody to store it, wait and hear back from them that they stored it, and then tell the client. Datomic does the last. That's durability. Now, does this mean it's infinitely durable? No. I mean, this is, in the scope of defining the ACID properties. It doesn't mean if an asteroid hits the Earth that the data is going to still be around, right? If the Earth is split in half by an asteroid collision, you might lose your data, right? If your data center is completely destroyed and the backup data center is completely destroyed, you might lose your data. But Datomic has done its part of the job, right? It has guaranteed that a durable storage service has said, I have this. That's the ACID properties. The ACID properties make software easy to write, and they make it easy to reason about. There are reasons not to want these, and those reasons mostly drive the NoSQL movement. But there are also lots of reasons to want these. And one of the ideas behind Datomic is that massive write scale is not the only thing you might want to change about existing SQL databases. It is something you might want to change. And there are a lot of NoSQLs that have done a great job of that. You look at things like Cassandra or DynamoDB that have done amazing things with write scale. But it's not necessarily the only thing you'd want to change. Now, transactions are always at the bottom just collections of assertions and retractions. And you can actually write them this way. You can write them in list form or tuple form. And this is add or retract. So that says, am I putting it in or am I negating it? The entity ID, the attribute, and the value. And you've seen some transaction examples that we've looked at already that have this shape. Notice that of the 5 things that actually get stored in Datomic, only 4 of them are present here. Add or retract, EAV. What's missing? Time or transaction. Right? You can't add that because who's in charge of that? The transactor has to do that. So you don't get to specify that. You get to do this, and then you'll get back a report that tells you when it happened and what the transaction ordering is. Now, as a convenience, you can make multiple statements about the same entity with a map. And most of the time when you're transacting, well, I don't know about most of the time, quite often, especially if you're a human writing transaction data by hand, which is what you are in these labs, then you're going to use the map form because it's more convenient if you're saying multiple things about the same entity. Right? Because if you're saying 6 things about the same entity, well, how many things do you have to make if you make it a datum at the time? 6 times 4 is 24. If you say it with a map, it's 6 times 2, 12. Right? You just put attribute value pairs in a map. These can also be nested. So if you look at, on the top, you have a list of assertions. So 5 tuples or 4 tuples, add, number, attribute value. And then at the bottom, you have the equivalent map form. What is the thing that actually gets stored in the database? It's always datums, because what is database? Database is just a set of datums, right? That's what it is. But in many cases, both on the input side and the output side, having this entity map form is a convenience. And it's also closer aligned with what we're used to if you're coming from, say, object-oriented programming, where objects look a whole lot more like this. Right? They look a lot more like things that have attribute value pairs than they look like bags of tuples. If you need to make a cross-reference, you can use the same DB twice, or more than twice, in a transaction. So here I'm creating Bob, whose name is Bob, and I'm creating Bob's spouse, and I'm doing both of them in the same transaction, and I'm specifying that they have this spouse relationship between each other, which means that I need to link them up, but these IDs don't exist yet. Right? If I made these IDs and came back later, I could use lookup refs, or I could use the actual numeric value of the ID. But at the time I'm making Bob, the transaction that's going to make Alice hasn't run yet because it's the same transaction, and vice versa. And so here I'm using Bob in person spouse. That person spouse is a reference attribute. So I'm putting a string value in. Datomic will see that and say, oh, that's a temp ID. That temp ID had better match a temp ID that appears as an entity ID. So in this case, DB ID. DB ID is special. DB ID is not really an attribute. Let me say that again. DB ID is not really an attribute. It is a way of adding the E back to this map, right? Because this map is attribute value, attribute value, attribute value, attribute value. You need to add the E back to the map only when you need to specify its ID because you need to refer to it more than once, right? So, or if you want to refer to an existing ID and you already know its value, right? So you don't have to put, right? You could leave ID out of this map. And if we weren't trying to say that Bob and Alice were spouses, Spice, then you wouldn't have to use the DB IDs here. Does that make sense? And everybody is having trouble with this lingo a little bit because the optionality of DB IDs happened with yesterday's release. Right, so that's an enhancement as of yesterday. Prior to yesterday, DB IDs, you always had to put them in.
And here you don't because it's inside the here you do because inside the transaction you're referring to that.
You're referring to it more than once and you're cross-referencing. But otherwise you wouldn't have to. It does. That implies that the person's spouse attribute here is a ref.
And also the person's name is a unique identifier?
It probably is, and it is in the sample code that I used to make this slide, but there's nothing that requires that here because the DB ID is going to uniquely identify this thing at the end of the transaction. The DB ID is going to be some famous large positive number, like 131333, blah, blah, blah. So it's going to get assigned a unique internal to Datomic reference. If you want to be able to talk about it without having to walk around with those giant numbers in your head, then you want to give it a unique ID, which person name probably is here.
Okay, so this could have just as easily been expressed as DBID capital B in quotes.
Yes.
Person name Bob, person spouse, capital A in quotes, and then on the next entity, same thing, except for the name remains the full name.
Yes, you could have definitely done this. Because those are only being used to link things together.
So that DBID, that's not saying the name of the database.
It's not saying the name of what?
The database. It kind of sounds like to me you're saying I'm identifying the database.
No, the DB namespace is like is about all the things that Datomic knows. So the DB namespace is reserved for things Datomic wants to talk about. So you shouldn't make any names that start with DB, and that's the only meaning of DB. It's not scoped to a particular database or anything like that. Yes? Does it have to be a string? Well, I mean, prior to yesterday, it couldn't be a string. So it used to look like this. That's what it used to look like. Yeah, it's awesome, isn't it? So this this syntax has two advantages over strings. One advantage over strings is that DB ID can, in certain cases at least, so that's an example of the extensibility. Remember, we can make your own data literal because of Eden. So this is an example. It's in fact the only example in Datomic of using that extensibility in a Datomic specific way. And making a data literal like that data literal can have a more compact representation than a string. It can have a straight up numeric representation under the hood. You don't have to know or worry about that. The second thing that database ID can do is it allows you to specify what's called the partition. So db.part/user is a partition which is a locality hint. putting these locality hints on data is a fairly advanced thing to do, and a vast majority of our users don't use it. And it's a kind of high price to pay because, and this goes back to how weak things like JSON are, like when we went to make the client API, this is the one thing, like, well, if we're going to have DBID, that's going to have a representation that we can make something useful out of in every programming language on the client side. And we're like, well, that kind of stinks. And now we're back to exactly the same world. It's like, well, do all these other languages have a symbol type? No. Do they have a keyword type? No. Do they have the extensibility to let you make a new type called DBID? No. Well, crap, what's left? Strings. So that's how you get sent back to just calling this in our new concise form B.
So if you have kept the DBID literal,
Yep.
you then have to type it in after spouse instead of A.
Yes, you would. Although remember, I mean, you don't want to get overly hung up on typing in transaction data by hand, because when you're actually building a system, you're not going to be doing that much. But yes, you would.
And is it true that the scope of this ID is the transaction?
The scope of the temporary IDs, capital A and capital B, is this transaction. They get turned into real IDs. The scope of the real IDs is permanent.
You couldn't have another transaction using the same.
Oh, you could, but they just don't refer to the same thing. Right? They're just like local variables in that way. Yes, Chris.
So I want to get back to a comment you made at the beginning of this discussion about DBIDs no longer being required. So for a moment, imagine that this person spouse attribute is not significant, and I just want to create an entity whose person/name is Bob. Is it sufficient to express that with just that pair
Yep.
in the map?
Yep, you could just do that.
Yeah. Okay.
Now, if you did this and you left the Alice in there, it would say, it would come back to you with anomaly, incorrect. The temporary ID B is used only in value position,
Right.
which means it doesn't correlate with anything in entity position, which means I don't know what it is.
Right. But the top.
But the top thing by itself would be fine.
Okay. And whether or not a new entity is created or not depends on the identity attribute in the schema for person name?
Yes, and also whether or not you specify an ID. So when you specify a DBID, you could specify the actual ID in the system.
But there I'm not.
But there you're not, right?
Right.
And so then if there is a person named Bob already in the system and it's unique, nothing changes. Well, there's two kinds of unique, which we'll see in a minute.
Right.
So we'll come back and talk about the differences between those. But yes, that's what unique gives you.
Okay.
Yes?
When you're using here with the alt style, temp IDs, you could do resolve temp IDs. Does it work with the strings now as well?
That's funny you should mention that.
Because when I look at my transaction data I get back, I see the temp IDs being converted to negative item int mapped to new int.
Yeah, the temp ID resolution has a bug in yesterday's release. And as soon as I'm done teaching the class, that will work. So that's the one thing I know it's not working right now is the temp IDs. The temp IDs that are returned from the transaction, they are in fact a mapping that is something that's meaningful to the transactor, but it's not meaningful to you. So it's not helpful right now. But that will be fixed before the week is out. There's another question. All right. Now, the super nice thing about these entity maps is that they can nest. So here, I'm creating a order. And you know what? I don't need that order ID either. That's kind of an important distinction. Whoops. Well, no, that's good. That's fair. Let's leave it like it is. Okay. So this is making an order. And probably the order would have more attributes, but I've just skinnied it down, right? The order might have other stuff. But this is making an order, which is an entity, which has a reference to line items, which is two new line items, where chocolate and whiskey are variables set earlier in the program that represent the IDs of those things that we want to order. This will, because it's nested, it will automatically make all the relationships for you. So you no longer have to keep track of the DBID of the order and true it up with the DBID of the line items which need to refer back to the order. This will make all those relationships for you. Hey, presto.
This creates a new entity.
This creates 3 new entities.
Yeah, 2 line items.
2 line items in an order, and it makes the references between them.
Chocolate and whiskey are symbols that refer to something that was
That was deft or lambda in, or it came in from somewhere else. I just didn't want to show all that stuff. They could just be numbers. It doesn't really matter. Yes, Francois. It means line items is cardinality many. So you're specifying more than one thing there. No, there's no order. So if you want to, it's like triple stores. If you want to model order in Datomic, you have to implement a linked list or a vector in triples. Right? And we can talk about that some, offline. But yeah, so order is not a big priority. It's not as first class.
If I
Yes.
heard his question right, you were asking, he's seen the vectors there. Why aren't those lists? Is that what you're?
Well, if they were lists, what would happen if they were lists?
The first item would have to be a function.
Well, not exactly. That's true. But continue with that. If they were lists, then Clojure would want to evaluate them, which would mean you would have to quote them. So it's not idiomatic in Clojure to use lists for things that are not code. A better argument would be, why isn't it a set? The reason that it's not a set is because of the number of other languages that are pathetic and don't have a built-in set type. And so thinking ahead to supporting those languages, there are lots of places where we didn't use sets. So
could you use any seekable there?
not any seekable, right? I mean, strings are seekable. But yeah, I mean, just use a vector. What is there a reason you want to use something else?
If you have some, you're creating a collection.
Yes, if you're creating a correction and something comes back like as a lazy seek, that's fine, right? But I would be careful about like set or things like that. But yeah, that's fine.
Set seems awfully expressive of what's happening,
It's exactly expressive of what's happening.
but not recommended.
Well, I mean, I can't even go back and remember, but we've tried to avoid using set literals because of the weaknesses of other languages in supporting them. Yes.
As a moment of definition of line items in the schema, I define that it should be unique. Will it solve the problem of uniqueness of this vector in line items?
Uniqueness is only global to the whole DB. So if I understand your question right, probably not. Right? I mean, what would be unique about the line item anyway? Like if you said product was unique, you could say no 2 people could ever order the same product. That doesn't seem very.
You said line item, not line items, right?
Line items, unique, and what I want to get is I want to define a collection which will have
No.
what I'm referencing to be unique.
No, you can't sneak your way into that, right? The uniqueness constraint is applied on a particular attribute, not on any kind of collection.
That would have solved my problem.
That would have solved your problem, but no. And the physics underneath that don't work, right? It's not like oh, we forgot to have a switch that you could flip that would do that. There are ways to solve that problem, and we will, but that's not it. Yes.
So in the context of Datomic, sometimes you'll refer to these data structures as lists, as you did a few slides ago, and that's just Datomic specific, right? I mean, usually with Clojure, that would be vectors.
Yeah, java.util.lists if you want.
What's that?
Java.util.lists, the Java interface that represents a list, right? And this catches people out sometimes. I mean, the Datomic, the peer library is defined in terms of the contract is in terms of Java interfaces, and that's the promise. The promise is not Clojure concrete types, right? Clojure concrete types are not going to have any meaning to non-Clojure consumers, and so Java's interfaces for collections, weaknesses though they may have, are the sort of least common denominator where you can talk about things. Okay, identity. We want to keep track of who's who. And Datomic provides several ways to do that, and it's super important to understand the differences between them. So Datomic has its own notion of identity that's relative only to the database, and you should treat as opaque. It happens to be a 64-bit number, but you shouldn't treat it as a number that you should do math with, right? It's an opaque identifier assigned by Datomic. Every time you make a transaction, it's either going to come back referring to existing entities by those numbers or new entities by those numbers. And how unique are those things? They're unique within the database. So, my record within this database is unique. A lot of times, though, you have external identifiers. So you have uniqueness that's semantic to your domain. And so there are a couple of different scenarios there. Sometimes you have an external ID that you're asserting that this thing is unique. Right? That it would be a mistake to say it for something like first name. But it's not a naturally unique identifier like a UUID. And so you will mark that as a DB unique / identity. That's a schema property. So we've already done this in schema when we define things. We've said this thing is a unique identity. And typically, that's going to be a string or a UUID or a URI that came from an external system. You might also want to assign a UUID. So let's say you don't have something that's globally unique being given to you. You don't have a data coming out of some other system that already has a uniqueifier on it. But you want to have a uniqueifier that's stronger than just system relative. You might want to assign your own global UUID. Again, that's just a DB unique identity, and it's a UUID. Datomic Peer includes squids, which is an API for making those. But in the absence of that, any UUID, random UUID generator is fine.
Is your performance hit on that?
On
UUID versus your built-in opaque?
Heck yeah. Of course, right? Global ID costs more than local ID. I mean, a GUID is substantially bigger than a 64-bit long. So yes, it costs to keep track of that. But on the other hand, globally unique identifiers are a super powerful programming tool. So I wouldn't shy away from them without having a real performance analysis that said why you would care. And then finally, there are programmatic names. So these are things like variable names in your program. Like if you were writing a program, you would say, int x equals 7 and string q equals Quizno and whatever, right? Those programmatic names in Datomic are typically used to name schema. So db/ident are typically used to name your attributes. But you could also use them for other things, right? If you had a set of enumerated types, like title, right? If you were getting people's information and you were allowing an enumerated set of titles, or if you were doing products and they came in sizes and that was an enumerated set, you might make idents out of those things, particularly if programmers would ever type them in their programs. Now, the thing you have to understand about DB idents is that they are faster than the database. Looking up something by an ident is faster than looking up something in the database. It has to be. Because every time you do a query, the first thing we do is use the idents to figure out what the actual thing we're querying on is. Right? So every query must do, a query might do dozens of these ident resolutions in order to even start doing the query. So what does that tell you about idents? How do they work? They're not stored they are stored in the database, but in addition to being stored in the database, they're stored in memory in every process in the system. Right? In every peer and in every transactor, every ident is stored in memory. Which, by the way, is, and if you go back to the analogy with a program, right? If you compile your program has a symbol table in it. And depending on, how that gets manifest in the compiled output, that might still be there in your compiled program. And if you had a program that had 1 trillion symbols in it, it might not be able to compile because you would run out of memory. Right? Does that mean your program can't manipulate 1 trillion pieces of data? No, it just means your program can't have 1 trillion programmatic names. Well, Datomic is the same way. And so it would be a mistake to use DB ident for every entity in your system. Let's say we just wanted to generate a random string or keyword name for every entity in the system. Right? Now you don't have a database anymore. What do you have? You have a big in-memory hash map. Right? That's not what idents are for. So it's important to use idents in the correct way. And this came up in the conversation that we were having over one of the breaks, where you were talking about a system that actually maps programmatic identifiers from another program and then you're putting it in the database. That may still be a sensible place to use idents or may not, depending on if you want to do that for one program or multiple programs. So, I mean, Datomic can support, and we'd have to look at the exact number it's documented, but it's, in the tens of thousands of, maybe even more than that, of idents in a single system. So it's not like these are scarce from the point of view of programmatic names, but they are scarce from the point of view of like number of entities you might have in the system. So you do not want to have a one-to-one relationship between idents and entities. All right. Transaction functions. Well, it turns out that you want to have richer semantics than just assert or retract. And the canonical example of this is you want to modify a value in the database based on its past value. So in database land, you don't take someone's bank balance, which is $100, and set it to $110. You do what? Deposit $10. But deposit's an operation which is functionally dependent on what the value was before. And this is what transaction functions are for. Transaction functions allow you to say, I want to have access to the prior value of something in order to decide what to do. And that means that transaction functions have to run in the transactor, which, because Datomic is a single writer system, means that they're sensitive performance-wise, right? They're at the very bottom bottleneck of everything. They're sensitive semantically. You can write your own custom transaction functions. I'm not going to talk about that today. Rather, I'm going to talk about the two that are currently built in. And because of clients shipping yesterday, there will soon be more built-in transaction functions. Retract entity you've already seen. Retract entity, instead of being assert or retract, it says retract entity followed by an entity ID. That produces however many retractions are necessary to make everything about that entity go away. Right? Which is that entity and its subcomponents and their subcomponents and so forth. And it will expand to all those inside the transaction, and then those retraction datums will go in the database. CAS stands for compare and swap. CAS takes an attribute, an old value, and a new value. And it says this transaction should succeed replacing the old value with the new value if by the time the transaction runs, that old value is in fact the old value. And what that is it's a check idiom that says, ooh, if that value is not the old value, that means I didn't know what I was doing. I was operating on stale data. I should fail the transaction and retry. And so for a broad variety of semantic correctness scenarios, CAS is like your Swiss Army knife. Conceptually, CAS is one of the sort of coolest concepts in software. Right? It's a very powerful tool that comes up again and again in different places. There are all kinds of other things you might want to use transaction functions for. Things like validating presence of multiple attributes to say that a particular entity is fully formed. Or validating relationships between attributes, saying that if an entity has this, then this other thing has to have a certain value or whatever. One could imagine that in the future, you might have something that was closure spec based. So you could say, I want to have a transaction function that just says, apply this closure spec to the data, which is awesome because it's super powerful, but it's not a doorway to arbitrary code executing. Or it doesn't have to be, right? It would have to be spec with a whitelist of predicates it was allowed to call. But that gets our users out of the business of having to write these things, and it gives a lingua franca for talking about what went wrong with your transaction, which again, as I said this morning, everybody should spend the 2 hours, right, to learn how to read spec error messages because they're not going to become less important anytime soon. So that is transaction functions. There will be more built-in transaction functions coming. And obviously, if you're writing peers, you can write your own. Yes? What's that? Oh, we've already seen it. I'll show you. It's easier than it sounds. Except for the having to switch displays, which is always harder than it sounds. Let's see. We used it first thing this morning in the CRUD example. Yep. They just look like, instead of add or retract, instead of db assert or db retract, it's just db some other name. And then you look at the doc string for that thing, which, by the way, let's just do that. How do I want to do this? Do I have a pull in here? Yeah, there we go. So instead of pulling this, I'm going to pull uh-oh. Yeah, there you go. So the built-in transaction functions have doc strings, and then they are more fully docked, and their parameters are docked on the website. Actually, that doc string could be a lot better. I wish I hadn't shown it. Yes, Siv.
Retract entity.
Yes.
So basically what it's doing is retracting. It's like a simple retract, but everything that it is related to.
Not everything that's related to, everything that's a component of it. Right? Remember, when you die, your arm goes away, but your friends don't go away.
Okay.
Your friends, you have a relationship with them, but they don't have to die just because you died. Don't be mean like that.
Okay.
Don't be so self-centered.
So data types.
Yes.
Right. So if I have a person there,
Yes.
person name say John,
Right?
and has friend Mike. So Mike is a ref. John is a string. Name,
Right.
Right. So if I retract the entity, does John go away? Mike doesn't go away from what you just said, right? Mike being an entity separated.
So you're trying to retract John,
Yeah.
and John's friend is Mike.
Yeah.
So there's all the datums about Mike, which you don't want to go away.
Yeah. So
There's
they don't-
all the datums about John, which you do want to go away. There's a datum relating John and Mike, which you do want to go away
Yeah.
because John doesn't exist anymore. And that's true regardless of whether John has a datum referring to Mike or Mike has a datum referring to John. Either way, John's gone, so that extra datum should go away. And it does.
Okay.
Right? That's what. So the right thing happens when you sort of work through what are the possibilities. There's a right answer, and that is the right answer. Yes.
From the history perspective, all of these advanced transaction functions will look like a combination of gets and removes.
So the question is, from a database history perspective, what are we going to see when these transaction functions run? You're going to see the output. You're going to see the result, right? You're going to see those datums, not the input. Now, you could imagine a future version of Datomic which stores for the record both the transaction input and the transaction output somewhere. And so then you could trace back and see not only the datums that were produced, but the transaction function that was called to produce them. It could be stored. It's not today. The feature request list just grows and grows and grows.
So when you're doing an add, transaction add, what if there's a nil value?
What if there's a nil value? The transaction will throw an exception. Datomic does not store nil. Right? The absence of something is the absence of something, not the presence of something with nil. And that falls out of that all of the attributes have types like int, not int or nil. And that matters semantically because dealing with nil doesn't make a lot of sense because it's an open schema anyway. It's not like you have to have a nillable column because we don't have rules about what columns are going to be there. Right? This is one of the positive sides of not having those kinds of structural things in place. The other thing mechanically is that Datomic can store things like integers in the most efficient way possible because it knows they're always going to be integers and they're never going to be nil, which in Java is still a pain, right, until we get better about fixed nums and not having to box things. So
when you're dealing with a lot of sparse data, you get a lot of nil kind of thing. What's a good way to handle? What's a pattern that's useful to handle, or idiomatic way of handling such data?
well, you just don't put it in. If it's nil, you don't bother to put it in. So remember that, let's say that your schema has 300 attributes in it, and 10 of them are normally associated with a particular entity. And you have an entity that walks up that only has 7 of those attributes. Fine, just put them in. Right? There's no rule that says it has to have all 10, just like there's no rule that says it can't have the other 290. There's just not a rule. Right? So, mechanically, if you already have maps in your programming language that have nil values, then you need to strip them out. Right? So then you just need to reduce that reduces and drops them out because Datomic won't like them. But you don't have to worry about that. There's no notion of not nil? I'm sorry, I'm having trouble hearing you. Yeah, no, there's no need for that. There's no need for that because there's no, I mean, there's two sides to it. I mean, Chris was pointing out some of the other side, the negative sides to it earlier, but this is a positive side to it, right? You don't have to worry about that because, right, not there is not there. There is there.
So you basically test for nil before you assert any.
Or you could let Datomic test for you. It'll throw an exception or an anomaly back at you if you have a nil value. It's not going to let you do it. Lab. So every transaction in Datomic is an entity, just like all the other entities in the system. So you have entity, attribute, value, transaction, and operation. That transaction is a reference to an entity which gets created with every transaction that represents the transaction itself. Which means that if you put 6 datums in the system, how many datums are actually going to be added?
7.
At least 7. Very good. At least 7. And the one that is automatically added today is dbtx instant, which is the wall clock time on the transactor that the data got added. The transaction identities themselves are non-decreasing. So you can walk up to a bunch of transaction entities and figure out which one came first just by looking at its numeric value, and that's fully consistent. Or you can ask when it happened, to the extent that you trust the clock on your transactor, by looking at dbtx instant. Also, Datomic will not let you cheat time. Right? So you cannot walk up to the transactor and say, it's 2014, assert a bunch of data, and then turn the clock back to 2012. The minute you try to assert a piece of data that's older on wall clock time than data that's already in there, Datomic's going to say, whoop, we don't go back in time. Right? We can't enforce that the clock be correct, but we can enforce that the clock move forward in order. So if you accidentally screw up your clock, you're going to be stopped. Yes?
So transactions are reified into entities like any other entity in the system, which means they're composed of
Entity, attribute, value, transaction, and op.
Right. So going meta on this, what's the transaction associated with the transaction?
So when you first create transaction 7, you're going to have a datum, which is transaction 7, dbtx instant, sometime was part of transaction 7. Right? 7 is going to appear in the E and the TX position.
Refers to itself.
Can refer to itself, that's fine. But you can talk about transactions later too. Right? So I could later go back and say something about transaction 7 like I didn't like it very much.
Sure.
Which is kind of important since we don't let you get rid of it. Right? I mean, everybody's so used to having mutable systems where if you don't like something, you get rid of it and leave no evidence. Right? We don't do that. We instead, you go back and say, boy, that transaction really ticked me off.
So that's kind of like your own custom excise.
It's not excise. I don't want to use that word. It's a way, yes. You can shun things all you want, but just don't get rid of them. And transactions have their own index, which is called the log, which means that you can efficiently walk through the system in log order, in the order that things happened, which is separate from the database indexes, which are not an efficient sort by time order, because time is a very low. All those indexes actually sort by all 6 attributes eventually, because they have to be a complete sort. But you notice they're only named by the first 4. Like, it's extremely unlikely that the 5th or 6th component of the sort is going to be of any actual use for locating things quickly. So here's an example of 2 examples of using the transaction entity. So if you refer to a DB ID named datomic.tx, that name is special. So strings that begin with Datomic should not be used by you as IDs, as temp IDs. Datomic.tx says, make these attributes part of the transaction. And here, I'm going to say publish at, and I'm going to say, for some other user of the system, I want this data to be visible only as of some date, which is publish at. Now, they're going to have to enforce that. They're going to have a query that says, find me transactions and then filter out the ones that aren't published yet, or something like that. But they can do that because this information has been hung on a transaction. The second example here is overriding time. So you are allowed to set the wall clock time. So I'm setting the wall clock time here to the 1st second of February in 2013, or the 0th second. of February in 2013. You can do that. Typically, the only time you're going to override transaction instant, TX instant is on an initial import. Now, here is a test your knowledge question, and it's fairly subtle. Let's imagine that you have built an application using Ruby and Active Record over a couple of years, and you've used the timestamp support that Ruby provides. So Ruby provides created at and updated at automation to help you with SQL tables. So you have a SQL table that had 7 columns in it, and then you add 2 extra columns, one for when the row was created and one for when the row was updated. How would you use those created at and updated at if you were porting that data to Datomic in order to produce this DBTX instant information? What's that? Well, you could take updated and just use it here.
Take the created and use it as the TX instant and add your own attribute for updated at. Use the updated at values.
So feel free to go and try to write this out on paper as a flowchart or try to code it up. But what you're going to discover is that you really can't without making some assumptions about what happened, because tracking created at and updated at is lossy. Right? Because imagine a table that has 7 columns plus created at and updated at. Which of those 7 columns was changed? And which of the 7 columns was created at any particular given time? At what granularity is Datomic data timestamped? At the equivalent of every single row column intersection in a SQL database is timestamped, right, with the transaction that made it. So it's not possible to reconstruct the history of your data. You just have to sort of pick something. Now, conversely, could you reconstruct created at and updated at in a SQL world from this? Of course you could, right? Because this is good. It's done right? It tells you when the different things were changed, right? Created at and updated don't tell you enough about change in your system. And so one of the things that people get a little bit worried about when they're importing data into Datomic, if they have managed time in their own system, is they get a little bit torqued about, can I translate the original notion of time from my system into what Datomic wants? And for most values of having done that, you can't, because what you did wasn't good enough to actually provide this information. However, nothing stops you from actually storing created at and updated at information that would say, look, we know this data came from a legacy system that had these other things, and we could still ask questions about that if we needed to. We don't know better than that, but we know that, so you could still store it, but you can't actually, recapture this kind of information. If you come to my talk at Conj on Thursday morning, I'm going to talk about doing ETL from SQL to Datomic, and I will show you another use of this. And the use that I'm going to show there is using an attribute on the transaction which is unique to the import and says whether or not this transaction has been run in the import yet or not. And that's going to be, right? So I'm just going to, and I'll tell you exactly how it's going to work. So I need to import the MusicBrainz database. This is what I'm going to do on Thursday. MusicBrainz has 100 million datums in it. I'm going to import them approximately 10,000 at a time in transactions. MusicBrainz is a perfect example of an existing system that doesn't have the time information, so I'm not even going to try. Right? It's just going to have whatever timestamps that it has. And I'm going to divide 100 million datums into 10,000 transactions of 10,000 each. And each one of those transactions, I'm going to give a unique name to. They're going to have famous names like MusicBrainz import 1, MusicBrainz import 2, MusicBrainz import 3. And I'm going to put those on the transactions, which is going to have it's going to have 3 purposes at least. One thing that's going to do is it's going to let anybody who looks at the MusicBrainz database know where it came from. They're going to know how it was imported because I'm recording that information in the transactions. And by the way, I can make up a really precise attribute. I could call the attribute, MusicBrainz imports .stu's laptop .date / happened or something like that, right? You can make a very specific name that's record keeping for that. The second thing that's going to do is it's going to make the entire import process fully restartable. Because I can import the data And I can look and see which transactions have run already because I can just ask the database, which of the import job have you done already? The third thing it's going to do is it's going to make it as parallelizable as my other choices will allow. So if I organize the data in such a way that it can be loaded in parallel, then I can just start firing off these transactions in random order. It doesn't matter. And which means I can run them as quickly as I can. Yes? Still only one transactor. Yes. But there's an advantage to firing off transactions in parallel because you get back to, remember I said before that when you submit a transaction to a system, it's not going to answer until durable storage has responded. Well, when I'm doing an import, I have a ton more knowledge, right? One, I know exactly what I'm doing. Two, I know I could throw the whole thing away, maybe, depending on in what context I'm doing the import. So because these transactions are idempotent, and they have become idempotent because they're decorated with this extra attribute on the reified transaction, then I don't have to wait to be told that the first one's in durable storage. I'll send them, I'll keep 15 of them in flight at a time, and now I'm saving the round trip overhead on every transaction. My import will go faster, and then if anything goes wrong, I don't care, I'll just start it again. Right? Because it's never going to accidentally submit the same data twice because I'm protected by the transactions attribute there. So there are a lot of things you can do with this. And Tim Ewald, some of you maybe even came to the Datomic mini conference last year before ClojureCon. Tim Ewald gave a talk on things you can do with reified transactions. And I would strongly recommend people go back and watch that video if this is interesting to you because it's a particularly powerful capability of Datomic. And it really drives home the power of having this information.
You said something a second on slow catching up processing this. But if anything goes wrong, you're confident that you won't insert something twice because I assume you've put a uniqueness constraint
on the transaction. That's right. That's exactly right. So by putting a unique value, and I use a unique value, not unique identity. So I alluded to this, but I didn't really say it. Unique identity says merge these things if they happen. Right. Actually, that would also work, but it would result in a cryptic error because it would try to merge a new transaction with an old one, and Datomic will never let you do that. There are all kinds of merge units. So there are all kinds of things you can try to say with unique identity to try to confuse Datomic. Like, so let's imagine that an entity had two different unique attributes. And then you said contradictory things about them in a transaction that could not possibly be reconciled by merging things together, then you're just going to get an error back. But a unique value is a better semantic here because it actually captures that you should see this once, and if you see it again, you don't like it. Yeah?
So I'm not sort of, bringing all of those legacy systems into Datomic. Because I'm thinking, like, the last time I had to do it, I brought over and added a column to all my tables and said, okay, my legacy ID is this, my legacy whatever. Would you, I guess from the ones that people have done, is it better to add those to your, your existing groups? So like, if you're adding a last updated or last whatever, or would you, does it make more sense to say like, I have a legacy set that basically says, okay, this ID was this, or does it matter at all?
I mean, so the question is, broadly speaking, there's a lot of choices in how to keep track of things when you're moving from one system to another, and where would you choose to do it? I mean, I think that for the job of doing the conversion, I'd be dominated for what was robust in the conversion. And so if you could come up with a reason why this would leave you restartable or better able to understand what went wrong if something failed, then if choice A wins over choice B for that, I would choose choice A for that reason. The other concern is, are you going to be asked to answer queries that talk about things that are really kind of only from the legacy system? In which case, you need to store that stuff and plan in advance or how you're going to query about it. In which case, you really need to capture that and give it good names in the new system. Otherwise, it can sort of fall off. Right? You could have that data. I mean, I've done the MusicBrainz import. I've done about 100 different ways, playing with it. And some of those ways included an intermediate Datomic database that was then thrown away at the end of the import, whose only job was to collect together correlation stuff that was needed by the job, but was not part of either really the source or the destination. As you'll see in my talk, I've now gotten more data-driven, and I've come up with ways to need less correlation, and therefore there's no need for that intermediate. There's no real benefit to that intermediate correlation database. But that's another thing you could do. All right. So the labs that are listed up here, I'm going to say avoid. And I'm going to recommend instead that for the lab you look at the tutorial. So there's two things to do during this lab, and it's sort of a dealer's choice, or you could do both. One of them is if you have not added data to your own system yet, add some data to your own system and look at it in the console and so forth. But the other is if you just want to get practice at looking at what adding data looks like, work through the tutorial, and I'll drop the link here. So here is the tutorial link, and then also the tutorial is, you can follow it in prose on the documentation site, and I'll drop that link as well. So if you're feeling like you're totally jamming on your domain, you can just dive in and keep working on your domain. If you want to sort of shore up some of the ideas we were just talking about, you can start by working through the tutorial and then making sure that all makes sense. And when we come back from the break, I will walk through some of the stuff in the tutorial and point out some salient points. Any questions before we break? And break.